Good morning, everyone. So we have finished the cofactor of A. Now let us go to the next problem. Now here we are supposed to determine the minors as well as cofactors. Okay. And this is again a 3 into 3 matrix. Okay. Now I am giving this as a practice question. I want you people to solve this as a practice question and send it to me before evening. Okay. Now we will go to another cofactor problem of 2 into 2 matrix. We solved 3 into 3 matrix cofactor. Now let us solve 2 into 2 matrix cofactor. Every step will remain same. So let us start. So cofactor of an element. First write down the formula. What is the formula? Element is Aij. Cofactor is Cij is equal to -1 to the power of I plus j into Mij. Okay. So first, cofactor of what is the first element? 2. So the 2 is in first row, first column. So -1 to the power of 1 plus 1 into what is the minor? What is the minor of 2? Can anybody say me what is the minor of 2? 7. So determinant 7. So now solve -1 to the power 2 into 7. Just write the determinant as it is. So -1 square is +1 into 7. So the cofactor of 2 is +7. Very good. Good. Now let us go to the next cofactor. Cofactor of 8. Now cofactor of 8. 8 is in first row, second column. So that is nothing but C first row, second column is equal to -1 to the power 1 plus 2. And what will be the minor of 8? Minor of 8 is -3. So -3. So -1 to the power 3 into -3. So -1 into -3 will give us +3. So cofactor of 8 is +3. Next, cofactor of what is the next element? -3, that is in the second row, first column. So if you see here, second row, first column, you have -3. So what is the minor of -3? Minor 8. So here -1 to the power 2 plus 1, this is 2, okay, into 8, that is determinant 8. So -1 to the power 3 into 8. Okay. So -1 to the power 3 is -1 into 8 will give us -8. So the cofactor of -3 is -8. Very good. Many of them have got the answer. And finally, the last cofactor of 7, that is second row, second column is equal to -1 to the power 2 plus 2. And what will be the minor? For 7, what will be the minor? 2 will be the minor. So determinant 2. So -1 to the power 4 into 2, which is +1 into 2, which is 2. Okay, so cofactor of A is equal to, write down the same 2 into 2 matrix starting from 7, 3, minus 8 and 2. So 7, 3, minus 8, 2. This is the cofactor. Understood? Any doubts in the cofactor? This is very important to understand for the adjoint. I mean the next concept and the inverse. Now can we go for the next concept? Okay. What is the transpose of a matrix? Interchange of rows and columns. Good, Gauri. Correct. Aina's answer is also correct. Okay. So we are supposed to find the transpose of a cofactor matrix. Now, how do we find cofactor? We know the formula. Minus 1 to the power I plus j into minor I and j. Okay. Now, this adjoint, after finding the cofactor matrix, if you find the transpose, that will become the adjoint matrix. Okay, and this adjoint is denoted by adjoint A, and that is how we get it. Yeah, correct, Lakshmi, interchanging rows and columns. Okay, now let us take this example. Now there is a matrix A. Okay, now for this matrix A, they have found the cofactors. Now the cofactors of this matrix A is 7, 3, minus 8, 2. This is the same problem that we did just now. Okay, the matrix is 2, 8, minus 3, 7, and the previous problem which we did, what was the cofactor we got? 7, 3, minus 8 and 2. Correct. Now if you find the transpose of this cofactor, that is called as adjoint A. Now, how do you find the transpose? The first row will become the first column. So, what is the first row? 7 and 3. This will become the first column, 7 and 3. The second row, minus 8 and 2, will become the second column, that is minus 8 and 2. Okay, so first you have to find the cofactor, and then if you find the transpose of the cofactor, that is called as adjoint of a square matrix. The square matrix can be 2 into 2 or 3 into 3 or so on. Okay, so that is adjoint of a square matrix. Understood? Understood adjoint of a square matrix? Now, using all of this, using the minor, then using the cofactor, adjoint, using all of these concepts, we will be finding out inverse of a matrix. Okay. Now, what is this inverse of a matrix? Let us understand. A square matrix B is said to be an inverse of a matrix A if B into A is equal to A into B is equal to I, where I is the identity matrix. So if you remember, when we did the multiplication of matrices, B into A and A into B was not equal. You will get a different answer. If you multiply A into B and B into A, you will get a different answer. But when you are finding the inverse of the matrix, so a square matrix B is said to be an inverse of A. When can I say it is inverse of A? When B into A will be equal to A into B. And both of them will be equal to an identity matrix. What is identity matrix? When the principal diagonal is 1. So if you see here, this is the principal diagonal and principal diagonal is 1 and rest of all the numbers are 0. So this is known as an identity matrix. Okay. So an identity, sorry, the inverse of a matrix is denoted by a to the power minus 1. If you just put a dash like this, it will become transpose. If you put minus 1, then it will become inverse. So while solving the problems, be careful even with the notations. What are they trying to ask? What are they expecting from you? All that you should understand by the notation. Did you understand inverse of a matrix? Got a fair idea? Yes. Now look here. This is repetition of the same thing from above. For a square matrix A, inverse of A is given as, how do we find the inverse matrix? They are saying you have a formula. A inverse minus 1 means inverse. A inverse is equal to adjoint of A divided by determinant of A. So what is adjoint of A? Adjoint is what we learnt here. If you find a cofactor and find the transpose of a cofactor, that is called as adjoint of A. Now to find a cofactor, you have to find minor. To find a cofactor, you have to find minor. So we will be using all the concept. We will be finding out minor. We'll be finding out cofactor. We will find the transpose of the cofactor. That will give us the adjoint. Now using adjoint, we will find the inverse. Okay. So if you want to find the inverse, you should know all of this concepts, that is adjoint, minor, cofactor. Clear? Understood? We'll go to the problems for you to get more idea, but until here the concept, did you understand? Yes or no? Okay, good. Then A inverse will exist if and only if determinant of A is not equal to 0. So what they are trying to say is this value, this determinant A should not be equal to 0. Okay. Why it should not be equal to 0? Because anything that is divided by 0 will not give you a proper answer. It will show you error. So the determinant of A, this value should not be equal to 0. Okay. Then that is called as matrix is a non-singular. We'll understand this in the next topic. Okay. Whenever determinant of A is not equal to 0, that is called as non-singular matrix. Okay. Now let us go further. There are two types of matrices that will be given here. So two types of matrices that are there. One is a singular matrix and other one is a non-singular matrix. Okay. So that singular matrix, what is a singular matrix? Now singular matrix is such that when the value of the determinant of that matrix is 0, that is called as singular matrix. Okay. So the value of the determinant, if it is 0, then it is singular matrix. So if you see here, matrix A is 1, 3, 3, 9. You have to find the value. How do you find? Cross multiplication. 3 threes are, sorry, first we have to start from here. 1 into 9 is 9, minus 3 into 3 is also 9. So 9 minus 9 is 0. So A is a singular matrix. Okay, and any matrix where this A, determinant A is not equal to 0, that will become a non-singular matrix. So the first condition for you to check out is the determinant value of a matrix should not be equal to 0. Okay, now we'll do one thing. Let us straightly get into the problem for you to understand the concept much better. Okay, so here is the first problem, that is find the inverse of A, that is a 2 into 2 matrix. Now in this 2 into 2 matrix, let us find out one after the other. Now firstly, in this 2 into 2 matrix, you are supposed to write the formula. So solution A inverse is equal to adjoint A divided by determinant of A. So this is the formula, adjoint A by determinant of A. Now we have to first find out determinant of A. So determinant A is equal to determinant values 3, 4, 1 and 2. Now can you find the value of the determinant? Find the value of the determinant and say me the answer. 2. Very good. So how did you find? 3 into 2 minus 4 into 1. So that's nothing but 3 2s are 6 minus 4 1s are 4, which is nothing but 2. Okay. So determinant A is not equal to 0. Correct. Everyone is correct. Good. Determinant A is not equal to 0. So which means we can find out the other values. Now let us write that. Since you have to write all this in exam, okay? Since determinant A is not equal to 0, that is A is non-singular matrix. A inverse can be calculated. Okay, A inverse can be calculated. Now let us find out. Now we finished finding determinant of A. Now let us find out the adjoint of A. Now to find adjoint of A, what is the formula? Adjoint of A is equal to cofactor of A transpose. Okay, adjoint of A is equal to cofactor of A transpose. And what is cofactor of A? Cofactor of A, that is Aij is equal to Cij is equal to minus 1 to the power I plus j into minor ij. Are you all able to follow? Are you all able to follow? Are you getting what I'm trying to teach here? Good, very good. Now let us all find out cofactor of A for the matrix. So let's start. So first one, we'll change the color here. So cofactor of, what is the first in the matrix? 3, right? So cofactor of 3. So what is the minor of 3 here? What is the minor of 3? 2. Everybody is clear with the minor? The minor of 3 is 2. Good. Now let us start. Cofactor of 3, that is C, first row, first column. This is very, very important. Do not miss the number of rows and columns. Okay, the whole problem will go wrong. So be very careful in the number of row and number of columns. So that 3 is in the first row, first column, which is equal to minus 1 to the power of first row plus first column, and then determinant minor. The minor of 3 is 2. Okay, so the minor of 3 is 2, and then calculate minus 1 to the power 2 into 2. So minus 1 to the square is plus 1 into 2. So the cofactor of 3 is 2. Okay, plus 2, correct. Cofactor of 3 is 2. Very good. Correct, 2. Now let us find the cofactor. Next, cofactor of 4. Now cofactor of 4, this is in first row, second column. Okay, is equal to minus 1 to the power first row, second column. What is the minor of 4? Can anybody say what is the minor of 4? 1. Good. Determinant 1. Correct. Very good. So minus 1 to the power 3 into 1. So minus 1 to the power 3 is minus 1 into 1, which is minus 1. So the cofactor of 4 is minus 1. Correct. Now next, cofactor of 1, that is second row first column, is equal to minus 1 to the power second row first column. And what is the minor of 1? 4. Okay, very good. Minor of 1 is 4. So minus 1 to the power 3 into 4. Minus 1 to the power 3 is minus 1 into 4, which is minus 4. So the cofactor of 1 is minus 4. And finally, the last cofactor, that is cofactor of 2. That's nothing but second row, second column, is equal to minus 1 to the power 2 plus 2 into, what is the minor of 2? What is the minor of 2? 3. 3 is the minor. Okay. So 3 is equal to minus 1 to the power 4 into 3. So plus 1 into 3, which is equal to 3. Okay. So what is the cofactor now totally? Cofactor of A is equal to, now write down all of the numbers. Yeah, correct. Cofactor of 2 is 3. Very good. Now write down the full cofactor. So what all do you get? 2, minus 1, minus 4 and 3. So 2, minus 1, minus 4 and 3. This is the cofactor of A. Okay. Now, how do you find the adjoint? Adjoint of A is nothing but cofactor of A whole transpose. Right? So, we have to find the transpose of this. So, what will happen? The rows will change to columns. So, what do we get? Adjoint of A is 2 and minus 1 will become the first column, and minus 4 and 3 will become the next column. Okay? Understood till here? Any doubts until the adjoint? Everybody understood? Good. Now, finally, we have to find out the inverse. Now, let us find the inverse. So, inverse of a matrix, that is A minus 1 is equal to adjoint A divided by determinant of A. Now, we know what is adjoint of A. This is the adjoint of A. So, write down adjoint of A, that is 2 minus 4 minus 1 and 3 divided by determinant of A. So, the determinant of A value was 2, right? So, the determinant of A value is 2. So, each and every element should be divided by 2. That will be 2 by 2 minus 4 by 2 minus 1 by 2 and 3 by 2. So, A inverse is equal to 2 ones are 2 ones are. So, 1 will be the answer. 2 ones are 2 twos are minus 2. So, here minus 1 by 2, it will remain as it is. And 3 by 2 also will remain as it is. So, this is the final answer of inverse of a matrix. Understood inverse of a matrix? Any doubts in this problem? Now, let us solve one more problem. So, I think it will be much clear with 2 problems. Okay? We'll solve one more problem. Inverse is very important. They can ask inverse for section C. That is, I think, 12 marks. 12 or 14 marks. Okay, new format. I'll just confirm and say 12 or 14 marks. It will be more than 12 marks only. So it's easy to do because you will have to show every calculation in detail. Then you can score full marks in inverse. Okay, now let us solve this problem. Now, again, what is the first step? We have to find the determinant of a matrix, right? So first write down the formula. Now here the matrix is B. So I will write it as B inverse. Okay, is equal to adjoint of A divided by, adjoint of B, whatever is the matrix name, write the matrix name. Adjoint of B divided by determinant of B. Oh, very good. People are fast. So find the value of determinant of B. That is 3, 5, 5, 12. So that's nothing but 12 into 3 is 36 minus 5 5s are 25. That is 11. So since determinant of B is not equal to 0, you can write it as determinant, you can just write B inverse exists. This one sentence you have to write, okay? Since the matrix is not equal to 0, so the inverse will exist. Oh, very good. So continue solving, Yashashwini. Okay, now B inverse will exist. Now our next step is to find the cofactors. So firstly, let us write down the formula, that is adjoint of B is equal to cofactor of B inverse. So cofactor of B is equal to Cij is equal to minus 1 to the power I plus j into Mij. So cofactor of 3 is equal to first row first column is equal to minus 1 to the power first row plus first column into, are you all writing, doing all the procedures? I mean, you're writing every step by step before getting the answer? Very good. Then correct. Continue doing it. So what is the minor? Minor will be 12. So minus 1 square into 12 will give me 1 into 12, which is 12. All got the same answer? Cofactor of 3. Next, cofactor of 5 is equal to first row, second column, minus 1 to the power 1 plus 2. And what is the minor of 5? 5. Nice, no? So minus 1 to the power 3 into 5, which is